Welcome to the peaceful space of sleep-friendly science, where we drift back through time to a world on the cusp of a dramatic and poisonous transformation for all life. Tonight, we journey to an alien Earth, long before our own. Picture a sky that wasn't blue and an atmosphere without the air we know. We will gently uncover the story of the first breath, when tiny microbes began to exhale a gas that would forever alter the destiny of our world. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Alien Home. Let us drift back now. Not across miles, but across time. Feel the present moment loosen its gentle hold on your awareness, like a ship untying its moorings from a familiar shore. We are not traveling outward to the stars, but inward and backward to the very seed of our own world. A time so distant that the Earth itself would be unrecognizable to you, a stranger in its own cosmic home. Imagine yourself floating in the quiet dark, a silent observer. Before you, suspended in the velvet black, is a sphere. It is Earth, yes, but an Earth of a different age, a different temper. 2.5 billion years have fallen away like grains of sand through an hourglass. This is the Archean Eon, a long, slow, planetary childhood. Let your gaze soften as you draw closer. The first thing you notice is the color. There are no brilliant blues, no crisp, white swirls of cloud as you know them. Instead, the planet is wrapped in a thick, hazy veil, the color of a smoky tangerine. The sky is not blue, but a soft, persistent orange, a perpetual, dreamy twilight. This is a sky thick with methane, a ghostly blanket that scatters the sunlight into hues of rust and amber. The sun itself is not a sharp, brilliant disk, but a diffuse, gentle glow behind this misty curtain, a softer, younger star whose light struggles to pierce the dense atmosphere. This atmosphere is not the air you are breathing now, the gentle, life-giving ocean of gas you draw in with every quiet breath. That air, your air, is a whisper of nitrogen and a gift of oxygen. But here, in this ancient past, the air is a different brew entirely. It is heavy, thick with nitrogen and carbon dioxide and that hazy methane. But of oxygen there is almost none. Not free, not available, not ready to be breathed. If you could stand on the shores of this nascent world, the air would have a strange weight to it, a foreign texture. It is an air that would offer no welcome to lungs like yours. It is an air that holds no promise of life as you have come to understand it. It is a silent, suffocating blanket. Now, let your perspective drift lower, through the orange haze, until you are hovering over the surface of the world's oceans. And here, another shock of color awaits you. The water is not blue. It is a deep, murky, almost olive green, not the vibrant turquoise of a tropical shoal, but a heavy, metallic green, the color of liquid jade mixed with shadow. This is an ocean of iron. For millions upon millions of years, volcanic vents on the seafloor have been patiently breathing dissolved iron into the water, and with no oxygen to react with, it simply builds up, saturating the seas. The oceans are heavy with this secret, holding a planet's worth of rust in a dissolved, invisible state. They are anemic oceans, in a way, waiting for a breath they do not know they need. Look upon the waves. They rise and fall with a slow, syrupy languor. They crash upon shores not of soft, golden sand, but of black volcanic rock and stark, gray basalt. There is no soil to speak of, not the rich, dark earth teeming with worms and roots that you know. This is a world of stone, the bones of the planet laid bare. Continents are small, restless things, still gathering their strength, drifting and colliding in a slow-motion dance that will take 1 billion years to find its familiar rhythm. Vast, dark plains of solidified lava stretch for miles, punctuated by towering volcanoes that sigh plumes of steam and sulfur into the methane sky. The landscape is raw, elemental, and profoundly silent. Listen. Listen closely with your mind's ear. What do you hear? There are no birds singing from unseen branches. There are no insects humming in the thick air. There is no rustle of leaves. No call of a distant animal. The deep, vibrant symphony of life that is the constant background to your own world is absent here. The silence is immense, geological. It is the silence of stone and water and sky. The only sounds are the planet's own slow heartbeat, the hiss of a geothermal vent releasing pressure from the world's hot core, the distant, low grumble of a volcano, and the gentle rhythmic lap, lap, lap of the iron-green water against the black rock shores. It is a soundscape of profound loneliness, a world waiting for a voice. And yet it is not lifeless. Life is here. It is simply hidden. It is a secret kingdom thriving in the shadows, in the deep places away from the pale, hazy sun. In the warm, mineral-rich waters around those deep sea vents, in the murky sediment at the bottom of the green oceans, and in thin, slimy mats clinging to coastal rocks, life persists. But this is a different kind of life. It is a world of the small, the microscopic. Archaea and bacteria, the planet's first and, for now, only inhabitants. They are a quiet, invisible hum beneath the geological silence. And all of this life, every single microscopic being, shares one fundamental truth. They are anaerobes. They live in a world without oxygen. And for them, this is not a limitation. It is a necessity. To these tiny, ancient beings, oxygen is not a gift. It is a terror, poison, a volatile, corrosive force that would tear their delicate cellular machinery apart. Their entire existence is built upon the careful, sacred absence of free oxygen. They thrive in the dark, in the deep, in the quiet, metabolizing sulfur and iron and hydrogen, performing a slow and patient alchemy that has sustained life for 1 billion years. This is the world as it exists, in a delicate, quiet equilibrium. A hazy orange sky, iron-green seas, black, rocky shores, and a silent, hidden kingdom of life that fears the very gas that gives you life. It is a world that slumbers, unaware that it is on the precipice of the single greatest transformation it will ever know. It is waiting for a new kind of life to emerge from the green depths. A life that will learn a new and dangerous magic. A life that will discover how to eat sunlight and in doing so will exhale a poison that will choke its creators, rust the oceans, and paint the sky blue. It is waiting for the world's first breath. For now, just rest here, in this strange, silent, alien home. Feel the immense, deep peace of a world before complexity. A world of simple, elemental truths. A sky of methane. An ocean of iron. A life that fears the light. Let the slow lap of the waves on the shore be a rhythm for your own quiet breathing. Section 2. The Whisper of Green. Stay here, in this quiet, ancient world. Let the slow rhythm of the iron-green waves be the only measure of time. For a long while, for ages that are impossible for a human heart to truly grasp, this is how the world is. A stable, sleeping giant. But in the warm, sunlit shallows, where the gentle light of the pale sun can penetrate the orange haze and the green water, something new is stirring. It is not a sudden arrival, not a dramatic thunderclap of creation. It is a whisper of green in a world of orange and black. This is the dawn of a new kind of being. It is life, but life that has stumbled upon a new philosophy. The older life, the anaerobes, had learned to live from the planet's inner warmth, from the chemical broth of the deep. They were children of the Earth's core. But this new life looked up. It turned its face to the sky. These are the cyanobacteria. Tiny, single-celled organisms no more than a slippery coating on a submerged rock, a faint green cloud in a tidal pool. They look humble, insignificant, and yet within their microscopic walls they hold the key to the planet's future. They are the quietest of revolutionaries, the most unassuming of gods. Imagine one of them now. A tiny vessel, a simple sack of life, drifting in the tepid water. But inside it has perfected a miracle. A tiny, intricate piece of molecular machinery that had never existed before. We call it chlorophyll. But you can think of it as a key. A sacred key forged in the patient furnace of evolution that fits a very specific lock, a particle of light, a photon. These beings, these cyanobacteria, learned how to catch sunbeams. All around them was everything they needed to build a life. The water they floated in was a vast reservoir of hydrogen. The air, dissolved in that water, was thick with carbon dioxide, a ready supply of carbon and oxygen atoms. But these ingredients were locked up, stable and content. To build themselves, to create the sugars that are the currency of life, they needed energy to break those bonds apart and reassemble them. The anaerobes found this energy in sulfur or iron. But the cyanobacteria found it in the sky. They learned to eat sunlight. This process, the solar alchemy, is a kind of magic. Picture it. A particle of light, having traveled 90 million miles from a young sun, spears through the methane haze, plunges into the iron-green sea, and strikes the chlorophyll molecule inside our tiny, green being. In that instant, the light's energy is captured. It is harnessed. And with that jolt of stolen solar power, the cyanobacterium performs its trick. It takes a molecule of water, H2O, and cracks it open. It is a powerful, difficult thing to do, like splitting a stone with a flash of lightning. From the shattered water molecule, it harvests the hydrogen. It then plucks a molecule of carbon dioxide from its surroundings. And with the sun's captured energy, it weaves them together, forging them into a sugar molecule. It is building itself. It is turning light, water, and air into life. It is a perfect, self-sustaining loop. As long as the sun shines and the water is wet, it can create its own food. It is a revolutionary act of independence. It has freed itself from the planet's chemical handouts and has learned to feast at the table of a star. This is photosynthesis, and it is a beautiful, elegant, and world-changing solution. But every process, even a magical one, has a consequence. A remnant, an exhalation. When the cyanobacterium splits the water molecule to get the hydrogen, something is left over. The oxygen atom. For the cyanobacterium, this single atom of oxygen is useless. It is a scrap from the workshop, a ghost from the broken water molecule. And so, the cell does the only thing it can do. It releases it. It breathes it out. A single, tiny bubble of pure, reactive oxygen gas. An afterthought. A puff of waste. In this world, a world defined by the absence of free oxygen, this exhalation is a profound and dangerous act. For a single cell, it is nothing. The tiny puff of poison immediately dissipates in the water. But this is not a single cell. They are legion. They bloom in the sunlit shallows, forming vast, slimy mats of blue-green. They cling together, layer upon layer, trapping sediment, growing upwards towards the light, building strange, stony structures we now call stromatolites. Living reefs built not by coral, but by bacteria. Each one a city of trillions of tiny, photosynthesizing beings. And every single one of them, in the gentle light of the hazy sun, is performing the same magic trick. And every single one of them is releasing the same ghostly waste. A trillion cells, each exhaling a tiny puff of oxygen. And then a trillion more. A quiet, continuous, and growing sigh, released into the waters of the world. It is a silent chorus of exhalations, a poison offered up with the innocence of a flower releasing its scent. For a long, long time, this poison seems to vanish without a trace. It has no effect on the atmosphere. The sky remains a hazy, smoky orange. The deep silence of the world remains unbroken. The cyanobacteria are not aware of the revolution they are fomenting. They are simply living, thriving, multiplying. They have found a niche of incredible success, turning sunlight into life with an efficiency the world has never seen. They are coloring the shallow edges of the continents with their distinctive green, a living fringe on the black, volcanic rock. They are the planet's new lungs, but they are breathing out a gas that the world is not ready for. So where does it go? This constant, steady stream of oxygen exhaled by trillions of beings, day after day, for 1 million years, and then 10 million, and then 100 million. Where's this poison hiding? It is dissolving into the water around them. It is creeping, unseen, into the great, green, iron-heavy oceans. The waste product of these tiny new lives is beginning to interact with the ancient chemistry of the world. The oxygen is meeting the iron. And a slow, planetary-scale reaction is about to begin. The gift of the sun is about to meet the blood of the earth, and the oceans themselves will be the proof. The whisper of green has released a whisper of poison, and soon the entire world will feel its sting. Rest with this thought. The image of a trillion tiny lives, each breathing out a single, invisible bubble. A revolution that begins not with a roar, but with a quiet, collective sigh. Section 3. A gift of poison. The quiet sigh continues. From the sunlit fringes of the dark continents, from the slimy, green layers of the living stromatolites, the exhalation goes on. A constant, gentle release of a new gas into the world's ancient waters. This gas, this oxygen, is the byproduct of a miracle, the waste from a feast of sunlight. And to you, listening to this story from the far future, oxygen is synonymous with life itself. It is the invisible river you are floating on with every breath. It is the energy in your muscles, the clarity in your thoughts. It is your friend, your partner in the dance of existence. But that is your truth, not the world's truth. Not yet. Here, in this deep past, this new gas is a terror. It is a ghost. It is a poison of unparalleled power. To understand the catastrophe that is about to unfold, you must first forget everything you know about this gas. You must see it through the eyes of the world it was born into. Imagine a library, ancient and vast, where every book has rested in its proper place for 1 billion years. The air is still, the silence is perfect. Everything is in a state of delicate, peaceful equilibrium. Now, into this library release 1,000 hyperactive children, blind and full of a chaotic, frantic energy. They would not mean to cause harm, but their very nature, their boundless, undirected energy would bring the quiet order to ruin. They would tear pages not from malice, but from pure, restless motion. This is what oxygen is to the Archean world. It is an agent of pure chemical chaos. The existing life on Earth, the vast, invisible kingdom of the anaerobes, is built on stability. Their world is one of slow, predictable chemical reactions. They pass electrons from one molecule to another with the gentle, careful precision of a watchmaker. This flow of electrons is the very current of their lives. But oxygen is not gentle. Oxygen is a thief. In the language of chemistry, this thievery is called oxidation. It simply means that oxygen is extraordinarily greedy for electrons. Its very atomic structure leaves it incomplete, with an insatiable hunger to pull electrons away from any molecule it encounters. It is fundamentally unstable, and it seeks stability by vandalizing the world around it. It is a rogue element, desperate to react, to bond, to burn. And burn is the right word. The fire that cooks your food, the flame of a candle, is nothing more than a very fast, very hot process of oxidation. Oxygen violently tearing electrons away from the fuel. But burning does not have to be fast or hot. Rust, the slow, crumbling decay of iron, is also a form of burning. It is a slow-motion fire, a patient oxidation that takes place over years. The browning of a cut apple left on a counter is a form of burning. The very process of aging in your own body is, in part, a story of slow, relentless oxidation. Now imagine this force, this invisible fire, being let loose in a world that has no defense against it. The tiny anaerobes, the life that has reigned for 1 billion years in the quiet dark, are like intricate, unwound clocks. Their delicate internal parts, their proteins and their DNA are all molecules rich with electrons, held in a perfect, fragile balance. When a molecule of this new, voracious oxygen gas bumps into one of them, it does not ask for permission. It rips an electron away. It oxidizes it. It burns it. The cell's delicate machinery shatters. A vital protein is twisted into a useless shape. A strand of its genetic code is corrupted. The flow of energy that is its life is short-circuited. For a single anaerobic cell, an encounter with a molecule of free oxygen is like being struck by a microscopic bolt of lightning. It is a profound, violent, and lethal event. This is the gift of the cyanobacteria. This is their great exhalation. It is a poison that dissolves cell walls, that unravels the very blueprint of life, that brings a slow, invisible fire to a world that has only ever known the dark and the damp. The cyanobacteria, of course, are not immune to their own poison. They are, after all, living beings. But in the same evolutionary stroke that gave them the magic of photosynthesis, they also developed an antidote. They became the first beings to create antioxidant-specialized molecules that could safely absorb the rogue oxygen, neutralize its frantic energy, and protect their own delicate inner workings. They had forged both the sword and the shield. They were living in the heart of the fire they were creating, but they had learned to wear armor of their own making. Everyone else was naked. Every other living thing on the planet was utterly, hopelessly vulnerable to this new chemical weapon. For a time, their doom is held at bay. For now, the poison is contained. The vastness of the ocean is a great buffer, and it holds a secret sponge that can absorb this toxic tide. The cyanobacteria continue their quiet work, pumping out their ghostly waste, unaware of the tension they are creating. The concentration of oxygen in the sunlit shallows begins to rise, a silent, creeping stain. The local anaerobes, the ones living near these new, green mats, are the first to feel the sting. They die. A silent, microscopic genocide begins in the sunlit shallows. A zone of death, of invisible fire, begins to spread around the very sources of this new life. The rest of the world still slumbers. The deep oceans remain a sanctuary, a haven for the old ways. The hazy orange sky is still untouched. The great, global catastrophe has not yet truly begun. But the poison is building up. The exhalation of a trillion tiny lives over millions of years is a force of geological scale. It is a river of toxicity flowing from the skin of life itself and pouring into the blood of the world into those deep, green, iron-filled oceans. The stage is being set for a reaction of planetary proportions. The world's first breath is proving to be a poison, and that poison is about to find its first and greatest victim. Not life, not yet, but the ocean itself. It is about to bleed rust. Rest now in this moment of quiet tension. The poison is spreading, but for now it is unseen. The world is changing on a molecular level. A change that will one day reach the sky, but first must overwhelm the sea. Section 4. The oceans bleed rust. The poison continues to seep into the world's waters. A slow, steady, and relentless tide of oxygen, exhaled by the green architects of this new age. For now, the atmosphere is safe. The sky remains a hazy, smoky orange. But the oceans, the vast, green, iron-souled oceans, are the front line. They have become the battleground between the old world and the new. And for 100 million years, they will absorb the blow. Remember the nature of these ancient seas. They are not the clear, blue waters you know. They are heavy with dissolved iron, ferried from the planet's molten heart by volcanic vents on the seafloor. For eons, this iron has floated freely, suspended in a solution, giving the water its strange, olive-green hue. It is a world of ferrous iron, an iron that is stable in an oxygen-free environment. But it is a chemical state of quiet vulnerability. It is waiting. Now, into this iron-rich water comes the oxygen, the relentless exhalation of the cyanobacteria. And when a molecule of free, reactive oxygen, that energetic thief of electrons, meets a dissolved atom of iron, an inevitable and profound reaction occurs. The oxygen does what it was born to do: it oxidizes. It steals electrons from the iron. And in that instant, the iron is transformed. It becomes ferric iron. And ferric iron has a completely different personality. It is not content to float freely, dissolved in the water. It is insoluble. It is heavy. It is, in a word, rust. Imagine it happening on a microscopic scale. A single, invisible bubble of oxygen leaves a cyanobacterium. It drifts. It bumps into an atom of iron that has been peacefully suspended for 1,000 years. There is a silent, chemical flash. A bond is formed. And suddenly, a tiny, solid particle appears where there was once only clear, green water. A microscopic fleck of rust. It is heavier than the water around it. And so it begins to sink. One fleck is nothing. A trillion flecks are a cloud. A trillion flecks, over millions of years, are a storm. A storm of rust falling from the sunlit upper layers of the ocean down into the silent, black depths. The cyanobacteria live only in the shallows where the light can reach them. So it is here, in the top layer of the world's oceans, that the poison is brewed. And as it is brewed, it immediately finds its antidote in the dissolved iron. The ocean itself is detoxifying the water, protecting the deeper world from the oxygen poison. But the cost of this detoxification is a constant, gentle, planet-wide rain of solid matter. The oceans begin to clear. Not a blue, not yet. But the heavy green of dissolved iron begins to fade. The water clarifies as its metallic soul solidifies and falls away. It is as if the very color of the water is precipitating out, sinking into the abyss. Down, down, down it falls, this endless blizzard of rust, through the dark, cold water column to the ocean floor. And there, on the seafloor, a new geology is being written. A new layer of sediment is forming. For 1 billion years, the seafloor has been dusted with dark volcanic particles and the microscopic remains of anaerobic life. But now it is being covered by a blanket of red. A soft, fine, ochre-colored dust settling over everything. The rust falls like a slow-motion snow, burying the old world in a new layer of oxidized iron. This is not a fast process. It is a geological breath drawn out over unimaginable spans of time. A few 100 million years. Think of it. The time that separates you from the dinosaurs is less than the time it took for the oceans to rust. Layer by layer, the seabed is painted red. We see the evidence today written in the stone of our own world. We find them in great, old mountain ranges in the deep cores drilled from the earth. They are called the banded iron formations. They are some of the most beautiful and telling rocks on the planet. Imagine a slice of this rock. It is striped, with alternating bands of deep, silvery gray and vibrant, rusty red. The gray bands are the old world sediments laid down when the water was still green and anoxic. The red bands are the new world, the layers of rust that fell from the oxygenated surface waters. The bands may represent seasons or cycles of cyanobacterial bloom and bust. A good year for photosynthesis, a thick red band. A volcanic eruption clouding the sun, a darker, grayer band. Each stripe is a page in the diary of a dying world and a world being born. The planet was breathing in and out on a timescale of thousands of years, and the ocean floor was recording that rhythm in stone. This great, slow bleeding of rust is the single largest chemical event in Earth's history. It is a planetary transformation of almost incomprehensible scale, and it is all being driven by the tiniest of living things. The cyanobacteria, in their sunlit paradise, are changing the very bones of the earth, all with their ghostly exhalations. They are cleaning the oceans of their iron, preparing them for a different future. But the supply of dissolved iron in the oceans, while vast, is not infinite. And the cyanobacteria are relentless. They continue to thrive, to multiply, to photosynthesize. The engine of oxygen production does not stop. For 200 or 300 million years, the oceans absorb the shock. The rust falls. The red layers build up on the seafloor. The deep ocean, below the sunlit zone, remains a refuge for the anaerobes, protected by the iron sponge above them. The world is in a long transitional state. But eventually, a tipping point must be reached. A moment when the last available atom of iron in the sea finds a partner in an oxygen molecule and falls to the bottom. A moment when the great sponge is finally utterly saturated. After hundreds of millions of years of patient absorption, the oceans can hold no more. The poison has finally overwhelmed the antidote. And the cyanobacteria continue to breathe out. Now, for the first time, when a bubble of oxygen is released into the water, there is no iron left to greet it, no rust to form. The tiny bubble of gas has nowhere to go. It saturates the water around it, and then, with nowhere else to go, it rises. It breaks the surface of the sea, and for the first time in the planet's history, a significant, steady, and growing stream of free oxygen gas leaves the water and enters the air. The war for the oceans is over. The war for the atmosphere is about to begin. Rest here with this image. A world ocean that has bled itself clean. A seabed covered in a red blanket of rust, a tombstone for an old chemical order. And now, the first bubbles of a new world, a new air, beginning to break the surface, carrying a gift that is also a poison up into the hazy orange sky. Section 5. The sky begins to change. The surface of the water shimmers. For hundreds of millions of years, it has been the ceiling of the world, a boundary between the green, iron-heavy water and the hazy, orange sky. Now, that boundary has become a gateway. The great sponge of the oceans is full. The last of the free iron has been pulled from the water, laid to rest in red bands on the ocean floor. And still, the cyanobacteria sigh out their unending breath of oxygen. Imagine yourself hovering just above the surface of that ancient sea. The water is no longer a deep, murky green. It has a new clarity, a nascent blue perhaps, though the orange light from the sky above still tints it with a strange hue. And now you can see it. A gentle, persistent effervescence. Tiny bubbles of pure oxygen gas rising from the sunlit depths, breaking the surface and vanishing into the air. It is a quiet, constant release. A leak. The planet's biological waste is no longer being contained. It is escaping into the atmosphere. For the first time, the composition of the air itself will begin to change in a meaningful way. Up until now, the atmosphere has been a thick, soupy mixture of nitrogen, carbon dioxide, and, most characteristically, methane. It is this methane that has given the sky its pale, rust-colored glow. Methane is a powerful greenhouse gas. It has acted like a planetary blanket, trapping the heat from the young, faint sun and keeping the Earth from freezing into a ball of ice. The planet's warmth has been dependent on this hazy, orange shield. Now, into this stable, ancient atmosphere comes the intruder, oxygen, that reactive, electron-hungry molecule. And just as it found a reactive partner in the iron of the oceans, it now finds a new partner in the methane of the sky. When a molecule of oxygen, O2, meets a molecule of methane, CH4, in the upper atmosphere, spurred on by the raw energy of ultraviolet radiation from the sun, a chemical reaction ignites. It is another form of slow burning. The oxygen attacks the methane, breaking it apart. It steals its atoms, reconfiguring them. The result of this reaction is two familiar and far more stable molecules, carbon dioxide, CO2, and water, H2O. This process is called the Great Oxidation Event. But it is not an event in the way a storm or an earthquake is an event. It is a slow, creeping transformation that takes millions of years. For a very long time, the amount of oxygen leaking from the oceans is tiny. It's like adding a single drop of ink to a vast pool of water. The effect is negligible. The methane haze remains. The sky stays orange. The world's climate stays warm and stable. The cyanobacteria continue their work and the oxygen continues to leak. Drop by drop by drop. Slowly, the concentration of oxygen in the atmosphere begins to build. From a fraction of a trace, it climbs. 1 part per million. Then 10. Then 100. It is still a tiny, tiny fraction of the air, but it is enough. The slow fire in the sky begins to burn more brightly. The rate at which methane is being destroyed starts to increase. Think of the atmosphere as a bucket being filled with methane by deep earth processes and ancient bacteria. For 1 billion years, that bucket has been full, overflowing slightly, maintaining the haze. Now, oxygen has drilled a hole in the bottom of that bucket. For a long time, the hole is small and the bucket remains full. But as the oxygen continues to pour into the air, the hole gets wider and wider. There comes a critical moment, a tipping point. The rate at which oxygen is leaking into the air finally becomes greater than the rate at which methane can be replenished. The hole is now wider than the tap. And for the first time, the level of methane in the bucket begins to drop. This is the moment the sky begins to clear. The thick orange haze, the planet's defining feature for 1 billion years, begins to thin. Imagine watching the world from your quiet, floating vantage point. Over a span of 1 million years, which would seem like a gentle, slow fade, you would see the sky transform. The deep, smoky tangerine color would soften. The sun, once a diffuse, soft glow, would begin to resolve into a sharper, more defined disk. The murky quality of the light would give way to a new, crisp clarity. The oxygen is scrubbing the sky clean. It is burning away the haze molecule by molecule. And as the methane haze disappears, the true color of the sky is waiting to be revealed. A sky composed mostly of nitrogen, when struck by sunlight, scatters the shorter, blue wavelengths of light most effectively. The orange of the methane was an impostor, a mask. The planet's true face was always blue. So, as the last of the methane smog is oxidized into carbon dioxide and water, the color palette of the world shifts. The sky, for the first time in its history, turns from a rusty orange to a brilliant, piercing blue. The oceans, now clear of their dissolved iron, reflect this new blue sky and become a deep, profound blue themselves. The world, as you would recognize it, is being born. A blue planet with white clouds of water vapor floating in the black of space. It is a moment of incredible, stark beauty. A planetary baptism. But this new beauty comes at a terrible, terrible price. The methane haze was not just a color. It was a blanket. A vital greenhouse blanket that kept the planet warm. Carbon dioxide, the byproduct of methane's destruction, is also a greenhouse gas, but it is far, far weaker than methane. It's like replacing a thick down quilt with a thin cotton sheet. The planet's thermostat has been broken. The insulation has been stripped away. And with the faint, young sun providing less warmth than it does today, the consequences are immediate and catastrophic. With a clear, blue sky, more of the sun's heat simply reflects off the surface of the planet and radiates back out into space. The temperature begins to plummet. The world has traded its hazy, orange warmth for a beautiful, blue, and deadly cold. The oxygen has given the planet a new face, but it has also plunged a knife into its heart. The slow, invisible fire in the sky has cleared the air, but in doing so, it has set the stage for a new and terrible power to take hold of the world. The power of ice? Rest here, in the cold, clear light of the new blue sky. A beautiful, terrible clarity has come to the world. The air is changing, but so too is the very lifeblood of the planet, its warmth. The first breath has changed the color of the sky, but it has also triggered a chill that will soon embrace the entire globe. Section 6. The Great Silent Dying. Let us descend from the cold, newly blue sky. Let us leave behind the chemistry of the high atmosphere and return to the waters and the shores below. For it is here, in the cradle of life itself, that the true cost of this new world is being paid. The rusting of the oceans was a geological event. The clearing of the sky was an atmospheric one. But the rising of oxygen was, at its heart, a biological catastrophe. For more than 1 billion years, a span of time so vast it renders human history to a flicker, the world has belonged to the anaerobes. They are not just a form of life, they are the form of life. From the deepest hydrothermal vents to the slimiest coastal muds, they are the undisputed masters of the planet. Their existence is predicated on a single, fundamental truth, the absence of free oxygen. Their intricate cellular cities, their delicate metabolic pathways, their very genetic heritage are all built for an oxygen-free world. To them, oxygen is not just a challenge, it is an absolute. It is death. Now, their world is being invaded by this invisible fire. The oxygen that has saturated the oceans and is now filling the sky is a poison that is becoming inescapable. The crisis did not happen overnight. It was a slow, creeping doom, a tide of poison rising over millions of years. At first, the only refuges were the deeps. The sunlit shallows where the cyanobacteria churned out their toxic breath became the first zones of death. Any anaerobe that drifted into these bright, clear waters was seared from the inside out, its life extinguished by the relentless chemical assault. But the deep oceans, far from the sun, remained a sanctuary. The abyss was still anoxic, a shadow of the old world. But now, with the oceans cleared of iron and the atmosphere itself becoming oxygenated, the poison has begun to sink. The very surface of the ocean, once a gateway for oxygen to escape out, has now become a gateway for it to invade in. The churning of waves, the mixing of currents, all of these processes begin to drive the atmospheric oxygen down into the water column. The sanctuary of the deeps is no longer safe. The poison is percolating downwards, from the blue sky into the blue water, deeper and deeper, year after year. Imagine being one of these ancient beings. A microscopic life form floating in the quiet, dark water that has been your people's home for 100 million generations. Suddenly, the water itself changes. It carries a new sting. A new, aggressive presence that your body has no name for and no defense against. It would be like the very air in your own room slowly being replaced by a corrosive, invisible acid. There is nowhere to run. There is nowhere to hide. The scale of this dying is difficult to comprehend. It was not a mass extinction of roaring dinosaurs or crashing asteroids. It was a silent, slow-motion holocaust. Trillions upon trillions of living beings, each one a unique vessel of life, simply ceasing to be. It was the great dying, the oxygen catastrophe, a wave of extinction that swept through the microbial world, wiping out countless species, countless lineages that had existed for eons. Perhaps more life perished in this slow, silent event than in all the other mass extinctions of Earth's history combined. The first masters of the planet were being driven to the brink of utter annihilation by the waste product of the newcomers. It was a planetary genocide with no malice, no intent. Just the inevitable consequence of a new and powerful way of life colliding with the old. The cyanobacteria were not conquerors. They were simply breathing. But their breath was changing the world into a place where their ancestors, their cousins, the entire foundation of life as it had been known, could no longer survive. Where could the anaerobes go? Where can you hide when the very water and air become your enemy? They were pushed into the last dark corners of the world, the forgotten places. They retreated deep into the thick, black mud of the ocean floor where oxygen could not yet penetrate. They found refuge inside the geothermal vents where the chemical broth was still rich and the oxygen was scarce. They burrowed into the earth itself, away from the toxic sky. They even found a strange and intimate refuge inside the guts of other, more complex organisms that would later evolve. The anaerobic bacteria that live inside your own digestive tract today are the direct descendants of these refugees. They are living relics of this ancient catastrophe, still hiding from the oxygenated world in the warm, dark, anoxic safety of your own body. Their kingdom was shattered. Their billion-year reign was over. They were now fugitives, living in the planet's slums, the ghettos of a new world whose very atmosphere was a monument to their defeat. The world that was once their home had become a hostile alien planet. And what of the architects of this apocalypse? The cyanobacteria? They thrived. They were immune to their own poison, protected by their antioxidant shields. With their competitors, the anaerobes, largely eliminated from the sunlit world, they were free to expand. They covered the coastlines in thick, green mats, their populations exploding in the new, clear oceans that allowed sunlight to penetrate deeper than ever before. They were unwittingly committing genocide and inheriting the earth in the same breath. This was the profound, paradoxical nature of the world's first breath. It was both a creative and a destructive force on a scale the planet had never seen. It was clearing the way for a new kind of life, a life that could withstand, and even use this powerful, energetic gas. But to do so, it had to first scour the planet of the old order. It was a changing of the guard, not through war or conquest, but through a slow, inexorable change in the very chemistry of existence. Rest here, in the quiet gravity of this moment. Feel the immense, silent tragedy of this great dying. A world of life vanishing, not with a bang, but with the slow, corrosive whisper of a poison that was also the key to a different, more energetic future. The planet was being purified by fire, but the price was the near-total extinction of its first children. Section 7. Painting the Sky Blue. The silent dying has passed, leaving a changed world in its wake. The old masters, the anaerobes, are scattered, clinging to life in the dark, forgotten corners. The new masters, the cyanobacteria, flourish under a sky they are actively creating. And it is to that sky we now return, to witness the final stages of this grand transformation. The oxygen has leaked, the methane has been burned away, but the process of painting the sky blue is more than just the removal of an old color. It is the careful addition of new layers, new textures, new protections. With the methane haze gone, the atmosphere has become brilliantly transparent, but it is also thin in a protective sense. The young sun, though fainter than today, still bombards the planet with harsh, unfiltered ultraviolet radiation. UV rays are a powerful, high-energy form of light capable of shattering DNA and sterilizing life. The shallow, clear waters that the cyanobacteria now inhabit offer little protection. The very sunlight that gives them life also carries a threat. For life to one day leave the safety of the water and colonize the bare, rocky continents, a more robust shield would be needed. And the agent of that shield was the very oxygen that was now flooding the atmosphere. Let us rise again, up from the blue surface of the ocean, higher and higher into the thin, cold upper reaches of the atmosphere. Here, some 10 to 50 kilometers above the ground, the story of the sky's final touch is unfolding. Oxygen molecules, as we have seen, are typically found in pairs as O2. This is the stable, breathable oxygen you know. But up here, in the stratosphere, it is a different world. The raw, energetic blast of UV radiation from the sun is at its most intense. Imagine a molecule of O2 drifting in this high, thin air. A high-energy photon of UV light, a tiny bullet from the sun, strikes it. The energy is so great that it splits the molecule apart, breaking the bond that holds the two oxygen atoms together. For a fleeting moment, we have two single, highly reactive oxygen atoms, O, floating free. They are unstable, incomplete, and desperately seeking a partner. One of these lone atoms might quickly find another lone atom and reform into a stable O2 molecule. But often, something else happens. One of these lone, reactive oxygen atoms, O, will collide with a stable, two-atom oxygen molecule, O2. In this collision, a new bond is formed. O joins with O2, and a new molecule is created, O3. This is ozone. Ozone is a remarkable substance. Down here, near the ground, it is a pollutant, a key component of smog, harmful to breathe. But up here, high in the stratosphere, it is a planetary savior. It is the Earth's sunscreen. The very process of its creation, the absorption of that high-energy UV photon to split an O2 molecule removes harmful radiation from the sunlight filtering down to the surface. But its protective magic goes even further. The ozone molecule itself, this trio of oxygen atoms, is also exceptionally good at absorbing UV radiation, particularly the more dangerous wavelengths. When a UV photon strikes an ozone molecule, the ozone absorbs the energy and breaks apart, splitting back into a stable O2 molecule and a lone oxygen atom, O. This lone atom can then go on to find another O2 and form a new ozone molecule, and the cycle continues. What emerges is a beautiful, self-sustaining cycle, a dynamic dance in the stratosphere. Oxygen molecules are split by UV light. They reform as ozone. The ozone absorbs more UV light and splits apart, only to reform again. It is a constant process of creation and destruction, powered by the sun itself. And the net effect of this high-altitude dance is that a vast majority of the most dangerous UV radiation is absorbed, its energy safely converted into simple heat, long before it can ever reach the surface of the planet. As the oxygen concentration in the atmosphere slowly rose, from less than 1% to several percent, this ozone layer began to form. It was like a transparent, invisible shield being woven around the entire planet. A film of protection, growing thicker and more robust as the oxygen levels climbed. This had a profound consequence for the life below. The cyanobacteria and other early life in the shallow waters were now shielded from the most damaging rays of the sun. The very poison they were exhaling was high above their heads, creating the conditions for their own long-term safety. It is one of the planet's most beautiful and intricate feedback loops. Life creates a gas, that gas creates a shield, and that shield allows life to flourish even more. The world was becoming safer. The sky, once a hazy orange tent, was now a brilliant blue dome, complete with its own invisible armor. The chemical transformation was nearing its completion. The air was becoming, slowly but surely, a modern-seeming atmosphere. It was clearer, safer, and rich with a powerful, energy-giving gas. But the planet had one more great trial to endure. The new blue sky, so beautiful and clear, had come at the cost of the world's warmth. The methane blanket was gone, and the new, weaker carbon dioxide blanket was not enough to compensate. The Earth was losing heat to space faster than the young sun could replenish it. The temperature, which had been plummeting since the methane haze cleared, continued to drop. The polar regions, once temperate, began to feel a deep and permanent chill. Water, the very medium of life, began to betray the world. It began to turn solid. The great climatic consequence of the sky's new color was about to reveal itself. The planet, having survived the poison, now had to survive the cold. A long, deep winter was coming for the entire world. Rest with this dual image. A planet wrapping itself in a protective shield of ozone, making the surface safe for the first time. And at the same time, a planet shivering, its temperature falling as the first great ice sheets begin to form at the poles. The breath of life had given the world a beautiful, safe, blue sky, but it had also pushed it into the arms of a global freeze. Section 8. The World in Ice. The new blue sky is a cold comfort. The shield of ozone woven in the stratosphere protects the surface from the sun's harshness, but the planet is shivering. The warm, methane blanket has been torn away, and the Earth is now exposed to the cold void of space in a way it has never been before. The delicate balance has been broken. The planet is now losing heat faster than it can absorb it from the faint, young sun. The chill that began as a subtle consequence of the clearing sky now deepens. It ceases to be a condition and becomes a presence, a power. It creeps from the poles where the sun's rays are weakest and begins its slow, inexorable march toward the equator. At the highest latitudes, the rain turns to sleet and then to snow. A snow that falls in winter and, for the first time, does not fully melt in the summer. Year after year, the white layer deepens. The weight of new snow presses down on the old, compacting it, squeezing out the air, transforming it into something new. Into dense, heavy, glacial ice. The planet has begun to grow its own armor. Slowly, these nascent ice caps begin to move. They are not static blankets, but frozen rivers flowing under their own immense weight. They grind their way across the dark, volcanic continents, carving valleys, scraping the bones of the world bare. The sound is a low, geological groan, too slow for any ear to hear, as mountains of ice begin to reshape the face of the Earth. And this spreading ice has a secret, terrible power. You see it every time you look at snow. It is white, and white surfaces do not absorb light and heat, they reflect it. This property is called albedo. A dark rock or a blue ocean will drink in the sun's warmth, but a sheet of white ice acts like a mirror, reflecting that precious solar energy straight back into space. This existence depends on liquid water and direct sunlight. As the ice sheet expands, it entombs them. It cuts them off from the light, their source of power. The great, green mats that fringed the continents are overrun by the glacial advance, scraped away or buried in deep darkness beneath the ice. The engine of photosynthesis, the very process that caused this crisis, sputters and dies on a massive scale. The production of oxygen plummets. The planet is suffocating its own lungs. Life, once again, is pushed to the brink. The survivors are the extremophiles, the hardiest of the hardy. Perhaps some cyanobacteria cling to life in the thin layer of water that might exist just under the ice at the equator, where the sun is strongest. Perhaps life gathers in the warm, dark oases around hydrothermal vents, reverting to the old, anaerobic ways of metabolizing chemicals from the Earth's core. The world becomes, once again, a planet of hidden life, a sparse and desperate ecosystem fighting for survival in a world that has become almost entirely hostile. For millions of years, the Earth remains in this frozen stasis, a beautiful, terrible, white marble, sleeping in the cold of space. It seems like a permanent state, a final chapter written in ice. How could it ever escape? The very ice that covers it reflects away the sun's heat, ensuring the planet stays frozen. It is locked in its own icy prison. But the planet is not dead. It just has a very, very slow heartbeat. And deep within its core, that heart is still beating. Volcanoes, the planet's primal force, are not silenced by the ice. They continue to punch through the frozen shell, releasing plumes of gas and ash. And in that volcanic breath is the key to the great thaw, carbon dioxide. While the engine of photosynthesis is dormant, the engine of volcanism is not. For millions of years, volcanoes continue to pump carbon dioxide into the atmosphere. Normally, the CO2 would be absorbed by the oceans and used by life, but with the oceans sealed under a kilometer of ice and life all but extinguished, there is nowhere for the carbon dioxide to go. It simply builds up in the atmosphere. For millions of years, the concentration of CO2 in the air rises and rises and rises. It is the reverse of what happened with oxygen. Drop by drop, molecule by molecule, the greenhouse blanket is being rewoven. Slowly, imperceptibly at first, the atmosphere begins to trap more and more of the faint sun's heat. Eventually, after an age in the ice, another tipping point is reached. The concentration of CO2 becomes so high that the greenhouse effect is strong enough to start melting the ice just a little at the planet's warmest point, the equator. A dark patch of open water, or perhaps just damp, dark rock, appears in the middle of the endless white. And now the feedback loop reverses. The dark water absorbs sunlight where the white ice reflected it. The small patch of water warms up. The warmth melts the ice at its edges. The patch of dark water grows. As it grows, it absorbs even more sunlight, which melts even more ice. It is a runaway thaw. The snowball begins to crack. The great thaw, once it begins, is thought to have been astonishingly fast in geological terms. In perhaps just a few thousand years, the planet shucked off its skin of ice in a cataclysm of unimaginable scale. The melting glaciers would have unleashed megafloods, carving canyons and reshaping the continents. The oceans, reawakened, would have churned with a new energy. The Earth was reborn a second time, first from fire and now from ice. It emerged into a new atmosphere, one now rich with both the oxygen that had caused the freeze and the carbon dioxide that had ended it. The world was now primed for the next great chapter. The survivors of the great freeze, the life that had endured in the cracks and the darkness, now emerged into a world that was both familiar and new. The stage was set for life to not just survive the new, oxygen-rich world, but to learn how to master it. Rest in the aftermath of this great, global fever and chill. A planet that nearly died twice. Once by poison, once by ice. But it has survived. The breath of life has proven to be a force of both immense destruction and, ultimately, resilience. Section 9. Life learns a new breath. The world thaws. The great ice sheets retreat in a torrent of meltwater, and the blue oceans breathe again. Life, which had been clinging on in the dark, warm refuges of the planet, now emerges into a world profoundly changed. The survivors creep out from the hydrothermal vents, rise up from the deep-sea mud, and are seeded from the equatorial oases that weathered the long freeze. They find themselves on a planet that has been scoured, reshaped, and reborn. And they find themselves in an atmosphere that is now permanently and irrevocably rich with oxygen. The great oxidation event and the snowball Earth that followed were a singular trial by fire and ice. There is no going back. The oxygen is here to stay. Before the freeze, this gas was a crisis, a poison that triggered a mass dying and a global catastrophe. But now, in the aftermath, life begins to see it differently. It is no longer just a challenge to be endured, but an opportunity to be seized. The greatest danger the world has ever known is about to become its greatest source of power. The secret lay with the survivors. Not just the cyanobacteria who had always possessed the antioxidant shields to protect themselves, but with other, smaller microbes that had managed to eke out an existence through the long night. In their struggle to survive in a world with rising, inescapable oxygen levels, some of them had, through the slow, patient magic of random mutation, stumbled upon a new kind of chemistry. They had evolved new molecular pathways, new enzymes, not just to neutralize oxygen, but to use it. This was the second great revolution in the history of life, as profound as the invention of photosynthesis. It was the invention of respiration. Think back to the old way of life, the anaerobic way. To get energy, those ancient beings would break down food molecule sugars, for instance through a process of fermentation. It was effective, it worked, but it was fundamentally inefficient. It was like getting the energy from a log by letting it slowly smolder and rot. It released a little bit of the energy stored in the wood, but most of it remained locked away. For every 1 molecule of sugar they consumed, they might gain 2 units of cellular energy, 2 units of what we call ATP. It was enough to live, but it was a life lived on scraps. Now, consider this new trick, aerobic respiration. A microbe with this ability would still take in that same molecule of sugar. But instead of just partially breaking it down, it would use oxygen as a tool. It would use that greedy, electron-hungry nature of oxygen, not as a threat, but as an engine. Oxygen became the ultimate destination for the electrons pulled from the food molecule. It acted like a powerful drain, pulling the electrons through a whole series of intricate cellular machines, and at each step of the journey, a little bit more energy was harvested. It was the difference between a smoldering log and a roaring blast furnace. By using oxygen to completely combust that single sugar molecule, breaking it down all the way to simple carbon dioxide and water, this new process could extract almost all of its stored energy. For every 1 molecule of sugar, an aerobic organism could generate up to 36 units of ATP. 36 units compared to the anaerobes, too. It was an energetic leap of almost 20-fold. Suddenly, a new class of life had access to a fire hose of energy in a world where everyone else was sipping through a straw. It was a superpower. Life had not just tamed the fire of oxygen, it had learned how to put that fire inside its own cells, turning a poison into a controlled, internal combustion engine of incredible power. This new, high-energy lifestyle changed everything. With this vast surplus of energy, life could afford to do new things. It could become bigger. It could become more complex. It could move faster. It could build new and elaborate cellular structures. The old world of single-celled organisms drifting passively was about to give way to something far more dynamic. And one of the most profound innovations powered by this new energy was a new kind of cell. A eukaryotic cell. For billions of years, life had been composed of simple prokaryotestiny, simple bags of chemistry like the bacteria. But at some point in this new, energy-rich world, a new arrangement was forged. One simple cell engulfed another. Perhaps it was a predator trying to eat its neighbor. But instead of being digested, the smaller cell survived, living inside the larger one. And in one of the most important moments in the history of life, this arrangement became permanent. The 2 separate beings became a single, cooperative organism. The larger cell would provide protection and bring in food, and the smaller engulfed cell, which happened to be one of these new oxygen-breathing microbes, would become a dedicated power plant. It would use its magical new respiration trick to process the food and supply its host with a torrent of energy. This was the birth of the mitochondrion. These tiny structures, these descendants of ancient, free-living bacteria, are in almost every one of your cells right now. They are the powerhouses of your body, the reason you can think and move and live. Every breath of oxygen you take is a message sent to the trillions of tiny, symbiotic power plants inside you, telling them to keep the fires burning. You are, in your very essence, a walking, talking community of anciently cooperating cells, a legacy of a pact made in the aftermath of the world's first great pollution crisis. With this new, complex, energy-rich eukaryotic cell as a building block, the stage was set for life to get truly ambitious. With so much energy, cells no longer had to live alone. They could afford to stick together, to cooperate, to specialize. One cell could become a skin cell, another a muscle cell, another a nerve cell. They could band together to form true multicellular organisms. The first simple animals, strange, fern-like creatures, and simple, jelly-like blobs began to appear in the oceans. The world was no longer just a silent, microscopic kingdom. It was beginning to crawl, to swim, to hunt. All of this complexity, all of this dynamism, all of this new life was built on the foundation of that one crucial discovery: how to breathe the poison. Life had learned a new breath, a breath of fire, and with it, it would build a new and far more wondrous world. Rest with this miracle, the image of a poison being transformed into a fuel. The dawn of a partnership, a tiny cell within a cell, that would power all the complex life that was to come. Your own breath, in this moment, is a direct echo of that ancient evolutionary leap. Section 10, a legacy in every breath. And so, the world you would recognize finally comes into focus. A world with a protective blue sky and deep blue oceans, a world with continents teamed not just with microscopic mats, but with the first burgeoning experiments in complex, multicellular life. The great, violent, and transformative childhood of the planet is over. The stage has been set. The 2-billion-year-long story of the world's first breath has laid the foundation for everything that is to follow: the explosion of life in the Cambrian seas, the greening of the continents as plants crawled ashore, the age of dinosaurs, and eventually, so much later, the quiet arrival of humanity. Every feature of the world you know is, in some way, a legacy of this ancient revolution. Look up at the sky in your mind's eye. Its blue color is a gift from the oxygen that cleared the methane haze. That same oxygen, in the stratosphere, forms the invisible ozone shield that protects you from the harshest rays of the sun, allowing you to walk on the surface of the earth without being scorched. Without that first poisonous breath, the land would still be a sterile and dangerous wasteland. Think of the ground beneath your feet. The vast deposits of iron ore that we have used to build our civilizations, our cities, our bridges, our tools are the fossilized remains of that great, planetary rusting. They are the red bands of stone, the memory of an ocean that bled rust for 100 million years, all because a tiny green microbe learned to eat sunlight. You are living in a world built, quite literally, from the debris of this ancient chemical war. And most profoundly, think of yourself. Think of the body you inhabit, resting here, in this quiet moment. Your own complexity, your own existence as a creature of more than 30 trillion cells, is a direct consequence of that energetic leap forward. The old, anaerobic way of life could never have powered such a complex and energy-hungry machine as a human being. The slow, smoldering fire of fermentation could never have fueled a brain capable of contemplating its own existence, of telling itself stories about the deep past. Your life is a high-energy life, a life of aerobic respiration. And the engines of that life, the mitochondria inside almost every one of your cells, are the direct descendants of those ancient bacteria that first learned the trick of taming oxygen. You are a walking, breathing ecosystem, a symbiotic alliance that was forged in the crucible of the oxygen catastrophe. You carry the history of this great event not in your memory, but in your very metabolism. And so, we bring our journey back from the deep past, back from the alien world of orange skies and green oceans, and back to this present moment. Back to your own quiet, rhythmic breathing. As you draw in your next breath, feel the air gently enter your body. This is not just air. It is a river of oxygen, a gas that was once the world's most terrifying poison. It travels into your lungs, where it is passed into your bloodstream, carried to every corner of your being. And there, in the quiet darkness of your own cells, it is delivered to those trillions of tiny, ancient partners. It is the fuel that allows them to perform their magic, to turn the food you ate into the energy that is you. The energy that allows your heart to beat, your mind to dream, and your body to slowly, deeply relax. Your exhale, the gentle release of carbon dioxide and water vapor, is an echo of their work. You are participating in this very moment, in the same chemical exchange that has powered complex life for more than 1 billion years. Every single breath you take is a testament to the survivors of the Great Dying. Every breath is a tribute to the cyanobacteria's dangerous gift. Every breath is a connection to the moment the sky changed color and the world was forever transformed. You are breathing the legacy of a world that learned to live with its own poison, and in doing so, unlocked a future of unimaginable wonder and complexity. The story of the first breath is not just a story about the distant past. It is a story about the air you are breathing right now. It is the story of how your own life is possible. The profound, poisonous challenge faced by the earliest life was overcome, and the result is the vibrant, breathing world you are a part of. The world's first breath was a sigh of poison, but it led, eventually, to your own peaceful, life-sustaining breath, right here, right now. And so, our journey for tonight comes to a gentle close. Let the echoes of this ancient story fade into the background like the soft, distant rhythm of the waves on a primordial shore. There is nothing more to learn, nothing more to analyze. There is only the simple, peaceful act of being. Feel the gentle weight of your body, supported and safe. Notice the quiet rhythm of your breath, an ancient tide flowing in and out, connecting you to the very beginnings of the world. Let go of the story and simply drift on that tide. May the deep peace of this ancient earth be with you as you float into a calm and restorative sleep. Good night.